Okay. The final speaker from Taiwan, Professor Kuan-Fu, who is a specialist in EM and also AI, I think. He would like to talk about the AI for POCUS, the applications of AI in emergency ultrasound. Prof. Chen, please.
Thank you for your introduction. I'm hoping I'm not the lead speaker because what I'm going to deliver to you is quite different from the previous speakers. I'm going to deliver to you some of the current application of AI for POCUS, as well as some of the future direction I think we can all participate. First, I have no conflict of interest. I'm not a consultant of any pharmaceutical or ultrasound device company. So the outline for my talk in the coming 15 minutes will be first talk about the pros and cons of POCUS, and talk about AI, whether AI can help or not, followed by the limitation of the current AI application and the niche for us, and share a little bit about our experience and the future direction. We probably all are very familiar with POCUS, the point-of-care ultrasound, and we all know the advantage of using point-of ultrasound include as one of the pillar in the physical examination, and it could be the next generation stethoscope that everyone should put one in their pockets, and we can use POCUS to answer simple but clinically relevant questions. And it could be carried out directly at the bedside. And lastly, it could be repeated as many times as possible. By the way, we often use multi-organ approach instead of single organ like other specialty and try to solve the problem from our patient. But POCUS also have some limitation. I still remember about 10 years ago when we first introduced POCUS to our department. Our consultant, Dr. Michael Buller from Canada, he ever speak to us say he doesn't believe ultrasound should be introduced in the ED because it takes too much time and training. So we can foresee that it requires specific training, and sometimes, and not even always, we need to combine the theory and practical practice in order to fulfill the purpose. So don't mention the time to learn and train ourselves. And we also need a lot of instructor, although it's good for us, right? And sometimes, and we can only do some simple and dichotomous decision. And of course, it's always operator dependent. So interperson variability becomes an issue. So can AI really help? You can see on the right-hand side, you can see there's a video clip from the company called the Echo News, which actually combined AI technique into their medical device. So the AI could imitate human cognitive process. That means AI can help us to learn, apply, or solve problems altogether. It can also smooth the process with the finger snap. And lastly, sometimes we have some redundant tasks. We want the AI to automate the process, such as disease detection, image segmentation, and sometimes we want the AI can help us to quantify the measurements. So here's one of the examples you see, one of the also the function that the Echo News provided for us is to identify the B lines and perhaps automatically measure the distance between V lines, or a given distance, the number of the B lines. So the AI could enhance some of the image and some of the education purpose. And maybe for some of you already know that GE has lots of AI related functions such as auto IVC, auto VTI, and auto B lines. But personally, I think the accuracy still need to be assured before we really apply those technology to our daily practice. Oops, I'm hoping to move on. All right. It's now moving forward, I apologize. Okay. The next is the AI guided procedure. As you can see on the left-hand side is one of the procedures that you can apply, although it's on the in the not the real cases, but we can foresee that it could be used on the real cases really soon. For this example, the AI could identify the structure automatically in real-time fashion. And how can we do that? Is actually a new technology called ULO. And ULO version 4 is actually developed here in Taiwan, the Academia Sinica. One of the professors, they developed this tool, so you can use that to automatically identify all those structures, either like this video clip, the cars, or anatomy structure in POCUS image. All right. I think I need a new laptop because. All right. So, it's really prime time for us to embrace AI technology. Take this article for example. This is one of the articles I've been invited to review about a couple months ago. One of the articles finally published in BMJ, they try to incorporate all the evidence and try to make conclusion for NHS in the UK to determine whether to to fund the AI software for the mammography or not. So on the left-hand side, you can see this is a ROC curve, the receiver operating characteristic curve. You can see the AI tend to be very sensitive, but not very specific. So their conclusion is it's not the prime time for us to, forget about the radiologists but embrace the AI. So how about the POCUS? This is one of the article published by Dr. Blavis, who ever delivered a talk in Taiwan last year in our annual meeting. This is one of the models they developed, try to identify IBC automatically, and let's see their accuracy. The kappa value indicate the inter-observer agreement. So you can see the deep learning model is performing relatively well with their attending physician. The kappa value is about 0.78, but be cautioned about the confidence interval. They have relatively small sample size, so the interval is really wide. How about deep learning with resident? It's not really well, but the resident, see, they are not doing as good as attending physician as well. So this is one of the first articles they published, and in the coming year, they published another article trying to validate their model on the POCUS machine. They compared the two experts who of course have a relatively good kappa inter-observer agreement, and the confidence interval is not as wide as the previous article, but pay attention on the quality of the image. They use the handheld device. I wouldn't tell you the brand, but you can send me the question. I will let you know what's the equipment they use. But pay attention on the low quality image. Kappa is doing really worse. So it depends on the quality of the device. That's also what I often, advise my fellow, residents. For those who are really guru, are really expert, you can use any device you want. But for a beginner, just, use the good image quality first. And then how about our niche? Yes, we often face the daily, clinical reasoning that is not able to be replaced by AI now, but you must know that many researchers are trying to do that, trying to incorporate many other models such as lab data or the patient history or different image modalities. So that's our niche, I believe. Take this one for example. This is an AI model using the deep learning algorithm. They try to identify the neonatal respiratory distress syndrome. For those who know the ARDS, adult respiratory distress syndrome, we often need to incorporate many different evidence, such as on the right-hand side, you can see, to make a decision. So this model is doing relatively well. They compare different kinds of deep learning model, and the accuracy is range from 60% to 90%. So what's the task for us in order to fill the knowledge gap, in order to get our niche? First, I think is to standardize the image collection. Although there's a lots of data bank available for other image modalities such as CAT scan or MRI, for ultrasound, we cannot find a good database. This is one of the database I found, but it's not for AI purpose. It's only for education. But for those who are interested in trying to see lots of different image, this is a good place to go. The other thing is we need lots of manpower and computing power in order to label and learn for the machine. On the right hand side, this is one of the database on Kaggle, and this is almost the only database I can found for the ultrasound image. On the left rows, you just can see the original ultrasound image for the breast cancer, and on the black and white one, you can see this is what the human has to do in order to teach the machine how to learn. So lastly, I want to share with you some of our recent progress in terms of applying AI on both image and both MRI image and ultrasound. So this is one of the first one we published this year. We want to use the deep learning model to do some segmentation classification and mapping for acute ischemic stroke. So we apply the deep learning model, which actually we compare different kind of deep learning model. This is one of the UNets. So we compare the UNet to see whether the machine, the computer, can identify the acute ischemic stroke lesion. So you can see we actually combine different kinds of image modality, including DWI and SegMap. And finally, we report the lesion on the brain region. So the last one is we want to do the 3D identification in order to tell the machine what kind of stroke we are having. So this is another application we use so to identify the lesion. You can see we already have an app available. It says prototype, and you can once you upload image, it could identify the lesion automatically, and it could also report the anatomical lesion. And in the future, we're hoping to tell the clinician what's the possible symptom the patient should have. All right. So the other one is really the POCUS image we apply. So this is one of the presentation one of our residents delivered last year, and also won the first prize in Taiwan. So we try to develop and compare different models to identify aorta automatically. Maybe you will ask why we need that, but let me tell you one story before I share the progress of this project. I still remember a couple years ago, one of our very enthusiastic resident approached to me saying, "Hey, Dr. Chen, I found a AAA on this patient." And this is very interesting experience because in that case, it's not really an aneurysm, but the spinal column. So that's just made me remember why we're doing this. And sometimes we can use this as the telemedicine to let the physician in the remote area and try to collaborate with them to apply the ultrasound technology as well. So in this project, we compare different kinds of deep learning model. One is the pixel level classification, the traditional one. The other is the image to image translation. So the UNet again is the one of conventional deep learning model that already won lots of prizes in the world, and we apply that one to teach our machine to identify aorta on the ultrasound image. The other one is very interesting. It's called the GAIN, the Generative Adversarial Network. If you know Google, it's a very famous Google map that everyone is using nowadays, but our landscape just change all the time. So in order to do the Google mapping, they developed the GAN associated test, which means once you have the image from the satellite, the GAN can automatically reproduce a similar image, but just take the other kind of noise out of the image. So we compared these models and found that the GAN is doing relatively well with less computing power and even better accuracy. So we also developed a web-based application prototype. Once you upload image, you can automatically detect aorta for you in fingers. Yeah. All right. So this is going to be my last slide, is to let you know the future direction. I think most of you already know that 2D or 3D image modality is not enough anymore. So many researchers are trying to see the contrast enhanced ultrasound, whether it could help us to identify the lesion or not, or maybe could use the shear wave elastography. And for AI researcher, we are hoping to incorporate all those images all together in order to develop better, assistant tool. And ultimately, I think very similar to other image modality, ultrasound radiomics could be the one that researcher could use as a tool. And lastly, we want to apply all these tools to develop high throughput feature for detection and for education purpose. I'm gonna stop here and have to answer a question that you might have.
Presentation. Right now, there so far hasn't been any questions posted up in the chat, so I would like to invite our audience members, if you have any questions to any of the speakers, could we just put it up in the chat.